Yo, what's up? It's your boy Mr. AC, and what I got for you guys today is going over primarily, and we are on year number, so let's go ahead and get started. All right, let's go ahead and get rolling on question number 2006B. Now, this one is a very tough one, so we gotta really do our best to make sense of this one here. A pretty tough one, so I usually wanted to skip form B's, so you can do form B's, but if there's enough discrepancies, we gotta go through. Okay, consider the differential function on the axis provided below. Go ahead and write the sketch field, so the 9 points indicated. Again, hopefully by now you got an idea how do we start these? We want to get what slope? Go ahead and say it. That's right, you got it right, 0 slopes. So what do I need to plug into this function to get 0? Well, 1. So that means when my y value is 1, I get slopes of 0. So I'm gonna go ahead, let me just get a new color because you can't see that. I'm gonna go ahead at y equals 1, we get slopes of 0. That already took care of 3. Capiche, sayonara, taken care of. Now, what about cosine? Well, we do know some things about cosine. Let me go ahead and put a unit circle. We do know that cosine is 0 at these points right here. 1, 0 and negative 1, 0, right? Now, that's obviously not going to work for us because of the fact that, we're never going to be able to divide. This is pi over 2. And this is 3 pi over 2. So we're never going to be able to, well, pi over 2, 3 pi over 2. So we're never going to be able to get these values and get a denominator of 2 because we're plugging in just 1. So we just got to now do this by hand, right? So I just wanted to show you, that was kind of my thought process, but I believe that's all the 0 slopes. So now let's go ahead and get rolling. Well, remember, I want to keep one thing the same. So I'm going to keep y equals 0 the same here because there's 3 points here, and then I'll do the same thing here. So if I plug in 0, 0 minus 1 is negative 1, negative 1 squared is 1. So all I'm left with, as a little refresher, all I'm left with is cosine of pi x, which means I just need to plug in my x value into here and get my solution. So let's go ahead and do it. If I plug in 0, what's cosine of 0? Because pi times 0 is 0. Cosine of 0 is this point right there. That is 1, 0. So this is 1. If I plug in 1 here, what is cosine of 1? Well, 1 times pi is pi. Cosine of pi is here. That is negative 1. So this is going to be negative 1. And if I plug in negative 1 here, I'm going to get cosine of pi times negative 1. That's going to give me cosine of negative pi, which is really, really weird. But let me tell you what that means, right? If I go this way, this is pi. If I go the opposite way, this is negative pi. So the negative just means reverse order, but you're still going to end up in this point here. So it's still going to be negative 1. So that should take care of those 3 points indicated for us here. Let's go ahead and move on to these points down here. Well, I'm going to plug in negative 1 to my function. Negative 1 minus 1 is negative 2. Negative 2 squared is 4. So now I'm going to get 4 cosine of pi over x, and then now I'm going to go ahead and plug in my x values. Now I already know what my x values are, so it's just a matter of plugging these in, right? We already know if we put cosine, if we put the 1 in, we get cosine of 0. Let's start with 0. Cosine of 0 is 1. 4 times 1 is 4. So this is going to be super steep right here, right? That's a very steep line. And then if I plug in 1, right, that's going to be negative 1. So that's a super steep negative 1. And then this is a super steep if I go over here, did I make this positive? Oh my gosh, guys, I think I accidentally made this one positive. Hold on one second. This should be a negative 1. My complete apologies. That should have been a negative 1, right? Same as this one right here. So then that means that if I plug in the negative 1, that means reverse order, still negative 1, negative 4. So then this is going to be a very steep line, that right, just the same as those two. So if you notice, these points right here are identical to each other, and then these two obviously are identical, but this one was a lot more steeper than this one, and then 3 slopes of 0. So hopefully that makes sense. All right, let's go to part B. There is a horizontal line with the equation y equals c that satisfies this differential equation. Find the value of c. Well, there is a horizontal line. That means we need a slope of 0. And guess what? We already know that the slope of 0 occurs right here at y equals 1. So for part B, we can say, there is a horizontal line. So I would write this down. I would copy this. There is a horizontal line with the equation y equals c that satisfies the differential equation. This value is c equals 1 because we don't even need to justify. Actually, it didn't ask to justify. So it's literally, we just say, we just literally write down is c equals 1, right? At y equals 1 is a horizontal tangent. So the c value is 1. And then that would be our final solution. So hopefully that makes sense. This was a little bit of a tougher slow field problem with the part B that seemed a little tricky. We're gonna move ahead and go on to part C now. Part C being a little bit tougher to do than the other one. Okay, let's go ahead and get rolling. This is a tough one. I wrote it out here. Find the particular solution y equals f of x. We got to find the original with the initial condition. So we got to do all of that process. So what do we got to do? Well, just like normal, hopefully this part's starting to become more routine. That's kind of my hope. So we're going to multiply dx to both sides like this. And then we're going to have to divide by y minus 1 squared, which is a little bit tougher to do. Obviously, you can see this one's already, just by me writing this out, looks really funky. The dx's cancel, these cancel. So let me go ahead and rewrite what we have so far. So if you look now, this is what we have so far. Notice I put a placeholder of 1 on the numerator like we always would here. These canceled out, the dx is canceled out. And then now we have this function right here. Now we can begin to take the antiderivative of this function. Now before I do the antiderivative, notice how we have a power here. In the previous year, it was ln, right? Because it wasn't a power. Because we have a power, I want to rewrite this, to be honest with you, before I do anything else. So let me show you what I would do real quick. So I would do something like this here. I would bring this back up on the numerator, and then we will get -2 on the power, right? Because if I flip this side and I'm not going to flip the right side, that changes the power of the exponent. So now I'm going to go ahead and take our antiderivative. Well, what do we do? Well, we're going to add 1, right? So we're going to get, let me write it, y minus 1 to the -1. We're doing the antiderivative, so we need to divide by that is equal to, well, what's the antiderivative of cosine? Well, the antiderivative of cosine is sine. So I'm going to do sine, let me go ahead and write that out, of pi x. And then what is the derivative of the inside? Well, the derivative of the inside of pi x is pi, right? If this was 3x, the derivative of 3x is 3. So the derivative of pi x is pi, but because we're doing the antiderivative, we need to divide by that, and then it's plus c. So there is my antiderivative, and then all I would like to do, again, this is a little bit of a tough one, is just rewrite it, right? I don't like negative powers, so I'm just going to rewrite this as 1 over. So we're going to get, what I did is I put this on the denominator. That's going to turn it to a power exponent that is, sorry, it's going to give you a positive exponent, which is 1 when we put it back on the denominator. And then I have this so far. Now I'm going to go ahead and plug in my initial conditions. I'm going to plug in 1 into the x value right here, and I'm going to plug in 0 into the y value down here. So basically, let me go ahead and just rewrite this whole thing, and then I'll come to it in a moment. Okay, so let me go ahead and walk you through what I did. I just kind of put some of the steps out, and then I'll show you what we did. 0 minus 1 is -1. -1 times -1 is +1. That is where this value came from down here. Sine of pi, if I was to go back to our unit circle, which was here, sine of pi would be in this value right here. Now you know this is -1 comma 0. Sine is your y value, so that's why I knew that this was going to be 0 here, and 0 divided by pi is 0, so that's gone. 0 plus c is c. 1 divided by 1 is c. So 1 divided by 1 is 1. So we get c is equal to 1 here. So now what do I got to do? I got to take this value and plug it back in. Well, where do I want to plug this one back into? Well, I want to plug this back into the one that is more efficient, or the one that's going to give me less work to do. I do not want to plug it in to this one here because this has a negative power. I would ideally love to plug this back into the one up here, this one, the one that we just worked on. So that's the one that we're going to do. So give me a moment. All I'm going to do is just literally get rid of the c now, and then just put +1, and then we'll talk about how to solve this out from here. I just copied and pasted it, and I put it right here. I put the +1 for the c. So let me just go ahead and rewrite this whole thing real quick. Okay, so let's go ahead and solve this out. So first thing I would like to do is multiply -1 to both sides, because I want to get rid of this -1 that's in the denominator. These cancel. So what I'm going to get is over here is 1 divided by y minus 1 is going to equal, well, this is just going to become negative sine of pi x, and I wrote so big that I might need to make a whole new copy here, -1. Now the last and final step, again, this is going to involve 2 steps here. Let me just go ahead and draw a little line zoom down here. Now the last and final steps for us to do is I need to get the y's on the numerator because I want it to be y equals. So I'm going to flip the left side. That's going to give me y minus 1 over 1. I don't need to put the over 1. And then I'm going to get equal to, well, I'm going to put like a big set of parentheses. We got to flip this. So this is going to be 1 divided by, and I'm going to put a set of parentheses here, and this is going to be negative sign pi x over pi minus 1. That's what I'm going to get here. I'm going to go ahead and add 1 to both sides, right? And I'm going to add it to the outside, and then I'm going to get y equals, and then this is going to be my final solution right here. I'll just rewrite it down here so that it's nicely organized. And then that's pretty much it. Notice how I just made sure to put the +1 on the outside. So this was a really hard one, but hopefully that kind of made sense. And it's always good to go through these ones because as the years progress, again, you're going to notice some of the difficulties start to rise a bit. So hopefully you guys enjoyed, man. I'm out. Take care. Capiche.